Hello viewers. So today we'll take the topic range of real functions. Viewers, in my previous video I have discussed in detail regarding the domain of real functions, and we have also discussed a lot of problems regarding the calculation of domain of real functions. So let us now discuss how to find the range of real functions. Suppose we have a function y is equal to fx, and it is from set A to set B. Clear? Now this set A is called domain. This is the domain set, and this set B is called the codomain set. Here we are talking of real functions, that is we restrict our domain and codomain and range to the set of real numbers. Clear? So now when we give the input x, or when x is operated by this f, we get y. So y is known as when suppose we have this diagram here, say this is the function f from set A to set B. Clear? Now if we have here x, then its image is y. So x is connected with the element y. So y is the range of, or y is in the range set of function f. Clear? So x, the image of x under f is y. Clear? Now it may happen that the range is equal to codomain. Clear? So what is range? So range is the set of all the elements belonging to set B, which are f images of the elements of set A, or the domain set. So what is range? So range is the collection of all those elements y belonging to the set B, which are the f images of the elements of set A. Clear? Let us take this example. Suppose we have a function f from set A to set B, and the set A is 1, 2 and 3. Clear? And the set B is A, B, C and D. Clear? Now here we have f of 1 is equal to B, f of 2 is equal to C, and f of 3 is equal to B. So here the elements B and C constitutes the range of the function f. So range is here, the range set is here B and C. Clear? What is domain? Domain is this set A, and A is 1, 2 and 3. And what is codomain? So codomain is equal to the set B. And what is B? B is this set A, B, C and D. Clear? So here the range is B comma C, because only B and C are the f images of the elements of set A. And here it is to be noted that the range set is a subset of this set B, or the codomain set. Clear? So viewers, now let us take some problems related to finding the range of real functions. Viewers, let us take this simple example. Now here, here we have to write the range of, this is the range of, find the range of fx is equal to 2 over x minus 1. Clear? Now here I am not discussing how to find the domain, because we have already discussed it in our previous video. But for the sake of beginners, let us take first the domain. So what is domain? Obviously the denominator is not defined, or fx is not defined for x is equal to 1. So here x minus 1 should not be equal to 0. Clear? So our domain is, the domain of f is the set of all real numbers excluding 1. Clear? Now we have to find, this is the domain. Now we have to find the range. Clear? So for range we will follow an algorithm here, and let us first let y is equal to fx. This is the first step of the algorithm. So we'll assume this function fx as y. So y is equal to 2 over x minus 1. Now let us solve this equation for x, or our aim is to find the value of x in terms of y. So here we will multiply this x minus 1 with y. So we have y x minus 1 is equal to 2. So this is yx minus y is equal to 2. This is 2 plus y, and x is equal to 2 plus y over y. Okay? So we have this relation between x and y when we have expressed x, the independent variable, in terms of the dependent variable. Y is the dependent variable and x is the independent variable. So we have x is equal to 2 plus y over y. So obviously here we see that x is not defined. X is not defined for y is equal to 0. For y is equal to 0. So therefore the range of f is, I am writing it here, range is equal to this is this. The range is equal to set of all real numbers excluding 0, because here y cannot take the value 0. In that case x will not be defined. Clear? Now let us find the range of this function. Fx is equal to x minus 2 over 3 minus x. So we will assume fx is equal to y. So we will write y is equal to fx and y is equal to x minus 2 over 3 minus x. Now we will solve this equation for x. So here we have y times 3 minus x is equal to x minus 2. Then 3y minus xy is equal to x minus 2. And then we have 3y plus 2 is equal to x plus xy. And then we have 3y plus 2 is equal to x and y plus 1. Clear? So therefore we write x is equal to 3y plus 2 over y plus 1. Clear? Now we have expressed x as a function of y here. Clear? So obviously x is not defined for y is equal to minus 1. So therefore, and what is y? Y is our range. So the range is the set of all real numbers excluding minus 1. Clear? I am writing it here. Range is equal to r minus 1. So we'll exclude minus 1 from the set of real numbers, because here when y is equal to minus 1, x is not defined. So our range is r minus 1 here. Clear? Now we have this problem. Find the range of fx is equal to x square minus 9 over x minus 3. So here's obviously here the domain is the set of all real numbers excluding 3 here. Clear? This is the domain, because for x is equal to 3, fx is not defined. Clear? Now to find the range, we'll assume y is equal to fx, and here we have fx is equal to x square minus 9 over x minus 3. Now we'll solve it for x. So here we'll multiply it with y multiplied x minus 3 is equal to x square minus 9. So we have yx minus 3y is equal to x square minus 9. So here we can write x square minus this is yx and plus 3y minus 9 is equal to 0. So we have got this expression. Clear? Now this is a quadratic equation in x, and from here we can find the value of x. Clear? So let us solve this quadratic equation. So first we'll solve it by using quadratic formula. So let us first find the discriminant. So discriminant is b square minus 4ac. Clear? This is b square minus 4ac. So b is minus y square minus 4ac. A is 1 and c is your 3y minus 9. Clear? So here we have y square minus y square is y square. So then we have minus 4 3s are 12y, minus 4 3s are 12y. Clear? And plus 36. Clear? Now this can be written as y minus 6. 2 6 are 12. So this can be written as y minus 6 whole square. Clear? Now our quadratic formula is x is equal to minus b plus minus square root of d over 2a. Clear? So let us substitute the values here. So minus b is your minus y, so it becomes plus y. We have plus minus, and this is a square root of y minus 6 whole square. Then we can write 2 times of a, and a is 1. Clear? 1. So we have x equal to y plus minus y minus 6. Clear? Over 2. Now if we take the positive value, so we have x is equal to y plus minus y minus 6 over 2. Now taking the positive value, we have x is equal to y plus y minus 6 over 2. Clear? So we have x is equal to 2y minus 6. 2y minus 6 over 2, which is equal to, and so here we have x is equal to y minus 3. Clear? So we have got x is equal to y minus 3. Viewers, we have got x is equal to y minus 3 by taking the positive sign, and we are not taking the negative sign because then we will have x is equal to 3. Clear? And which is not possible because in domain we have r minus 3. The value of x is equal to 3 is not admissible. Clear? See, here if we take a negative sign, then what we'll get? We'll get x is equal to y minus 6 over 2. Clear? And this gives us y minus y get cancelled, and this is minus minus plus, so we have 6 over 2, that is 3, and x is equal to 3 is not possible because we have the domain r minus 3. So we'll take only the positive sign, and when we take the positive sign we have x is equal to y minus 3. Now here we have an interesting point. Now by solving x is equal to y plus minus y minus 6 over 2 and taking the positive sign, we have got this equation. Now what does this equation tells? At the first glance, this equation tells that the range is the entire set of real numbers, but this is not true. Why? Because x cannot take value 3. This x cannot take value 3. So when x is equal to 3, y becomes 6, because when x is equal to 3, y becomes 6. We'll substitute x is equal to 3 here, so y is 3 plus 3, 6. I am repeating once again. See, after solving this equation, we have got this expression x equal to y minus 3. Clear? We have already rejected x equal to 3. So we have x equal to y minus 3. Now from this equation, at first glance, it seems that the range is the set of all real numbers. But see, in domain, we cannot have x is equal to 3. So when x is equal to 3, the corresponding value of y is 6. So therefore, the range of f is r minus, and will exclude 6 because we cannot take y is equal to 6. So viewers, this is an important concept here, and which is to be remembered, that from this equation we see that, or it seems to us at first glance, that the range is equal to the set of real numbers, but we do not take x is equal to 3, hence we cannot take y is equal to 6. So we must exclude 6 from the set of real numbers, hence the range is r minus 6. Viewers, now let us take this example. Find the range of fx is equal to x minus 2 over 2 minus x. Now what is the domain of this function? So obviously we see that the function fx is not defined for 2 minus x is equal to 0 or x is equal to 2. Clear? So therefore the domain of f is the set of all real numbers excluding 2. Clear? We cannot take x is equal to 2 here. Clear? Now let us find the range. So this is domain, and let us find the range. For range, we'll follow the steps. Y is equal to fx. We'll substitute the value of fx from 1, and it is x minus 2 over 2 minus x. Let us multiply it here. Y multiplied 2 minus x is equal to x minus 2. Now here we will have 2y minus xy is equal to x minus and then we have 2y plus 2 is equal to x plus xy. By rearranging this equation, now we have 2 common here, y plus 1, and we take x is equal to 1 plus y. So what is x? X is 2 multiplied y plus 1 over y plus 1. Clear? Now, viewers, this is also a very interesting case here. Now, if I cancel out y plus 1 and y plus 1, I am going to get x is equal to 2. But in domain, we have seen that x is equal to 2 cannot be taken. Clear? So, what will we do here to find the range? Clear? So, from this equation, this is a very interesting case here. Now from this equation, we see that x cannot take value 2. So what does it mean? X can take any value other than 2 in the set of real numbers. So let us, for instance, let us take a value, say x is equal to 3. Let us take this value, x is equal to 3. So here we'll substitute the value of x is equal to 3. So what we'll get, I'm solving it here. 3 is equal to 2 times of y plus 1. Here we have y plus 1. Now we'll solve it. 3y plus 3 by cross multiplying here. 3y plus 3 equal to 2y plus 2. Now we'll solve it. 3y minus 2y is equal to 2 minus 3. So this is y is equal to minus 1. So we get only y is equal to minus 1, and y is our element in the range set. So from here we conclude that the range is minus 1. So let us take one more example here. Say if we take x is equal to, say we take x is equal to 4. Now what will happen? Let us see. Now let us see what will happen if we take x is equal to 4. So we'll substitute 4 here. So 4 is equal to 2 times y plus 1 over y plus 1. Now we solve it. 4y plus 4 is equal to 2y plus 2. Okay. Now this is 4y minus 2y is equal to 2 minus 4. So this is 2y is equal to minus 2 and y is equal to minus 1. So again we are getting y equal to minus 1. Here also we were getting y is equal to minus 1. So we conclude that if we substitute any value of x, you can test or you can verify it by yourself by substituting some more values of x in equation 2, and you will realize that, or you will come to the conclusion that in all cases y is equal to minus 1. So in this case our range is only this set, that is y is equal to minus 1. So we'll have the range set as minus 1, or the range set will contain only one element. Clear? Now we can justify or we can explain this result by one more method. Okay, and the method is see, here we have fx is equal to fx is equal to x minus 2 over 2 minus x, and we assume that y is equal to fx. Clear? Now if I take minus sign common from denominator, what we will get? X minus 2, and we have minus of x minus 2. Now clearly x is not equal to 2 here, as we have already discussed in while finding out the domain. So x is not equal to 2, and the rest of the values, that is apart from x is equal to 2, this factor and this factor gets cancelled, and we are left with only y is equal to minus 1. So this is the range of this function fx. So in terms of notations, we can write f is the function defined from the domain set A to the codomain set B, and here this set A is we have r minus, this is r minus 2, clear, 2. The range set is only minus 1, this is minus 1, clear. So in terms of a diagram, if we have this set as A and this set as B, and this is the function f, suppose we have here we have the set A, and this is the set A, and this is the set B, say consisting of all real numbers here, and since we have the range set as minus 1 only here, so here we'll have minus 1, and the other real numbers will be lying along with minus 1, and all the elements of this domain set A, that is r minus 2, here 2 will not be present, and all other real numbers will be there. So all these numbers will be connected to this minus 1, clear. So this is the meaning of range of real function in this example. Here we'll have all the real numbers except 2. Here 2 is not present, here 2 is not present, clear. And here in this set B, suppose if I take this set as codomain set, then it will contain all real numbers, but our range will consist of only one element, that is minus 1, clear. And all these elements in set A, which is the domain set, has the image as minus 1 only, clear. So minus 1 set, which is the range set, range of f, clear. Range of f is a subset of the set of real numbers, clear. And viewers, this is a very interesting case, and such functions are known as many one functions, clear. Such functions are known as many one functions. So viewers, let us take another example. We have to find the range of fx is equal to square root of x minus 1. As we have seen in the previous video, the domain of f will consist of all those values of x for which x minus 1 is greater than or equal to 0, or x is greater than or equal to 1. And if this is the real number line, and if we have here 1, so x is greater than or equal to 1, so we'll have this portion of the number line, and including 1. So the domain is closed interval from this side 1 to infinity, clear. So this is the domain. Now we have to find the range. This is domain. Now we have to find the range. For range, we'll assume y is equal to fx is equal to x minus 1. Now squaring both sides, what we'll get, y square is equal to x minus 1. Now we'll solve the this equation in terms of y, or we'll express x in terms of y. So x is equal to y square plus 1, clear. So this is the relation between x and y. Now from this relation, square root of x minus 1 equal to y, we see that y is always because x is greater than or equal to 1. So obviously y is always greater than or equal to 0. Clear? So therefore here from this relation we see that the least value of y is here 0. So if we take the value of y equal to 0, so x will be from 1 to infinity. Clear? 1 to infinity. So therefore the range of f is from 0 to infinity, because y is greater than or equal to 0. So y starts from 0 and goes to till infinity. Clear? So this is the range, and this is the domain of f. Viewers, now let us take one more very important example. Find the range of fx is equal to square root of 9 minus x square. Now for domain, I have already solved these problems in that video related to domain of real functions. Then here we have domain of f is equal to, for those values of x for which 9 minus x square is greater than or equal to 0. So minus x square is greater than or equal to minus 9. Multiplying both sides by negative sign, the will get x square, and the inequality sign get reversed here. So we will have this, and this is 3 square. Clear? So x lies between minus 3 and 3. Clear? So therefore x belongs to minus 3 to 3. Clear? So domain is the closed interval minus 3 to 3. So this is the domain. Clear? Now let us find the range. So for range we will take y is equal to fx, and y is equal to fx is square root of 9 minus x square. Now taking the squares of both sides, we'll have y square is equal to 9 minus x square, and here we have x square plus 9 square is equal to 9. This is the equation of a circle having origin at having center at origin and radius as 3. Clear? So we'll write x square is equal to 9 minus y square. So this is the relation between x and y when x is expressed in terms of y. So let us find the range. So from here we see that this was this was y, and y is greater than or equal to 0. Clear? Because this 9 minus x square is greater than or equal to 0, therefore, and we have assumed square root of 9 minus x square equal to y, so y is obviously greater than or equal to 0. So when we apply this fact to this equation, we come to the conclusion that the value of y varies from 0 to 3. 0 to 3. Clear? Why? Because when y is equal to 0, we have x is equal to 3. Clear? And when y is equal to 0, then x is 3, and when y is 3, then x is 0. So therefore our range, I am writing it here, so range is from 0 to 3, or y belongs to 0 to 3. Clear? Let us consider one more example. Here we have to find the range of fx is equal to 1 over x minus 7. Obviously this function f is not defined for x minus 7 is equal to 0 or x is equal to 7. So therefore x should not be equal to 7. Hence we can say that the domain of fx is the set of all real numbers excluding 7. Clear? So this is the domain. Now to find the range, we'll substitute y is equal to fx, or we'll assume y equal to fx. Now this is fx is 1 over x minus 7. Now we multiply x minus 7 with y. So what we'll get? Y times x minus 7 is equal to 1. Then we get yx minus 7y is equal to 1. And yx is equal to 1 plus 7y, and x is equal to 1 plus 7y over y. Clear? So here we have expressed x in terms of y. Clear? And from here this relation, we see that x is not defined when y is equal to 0. So here y should not be equal to 0. So therefore our range is the set of all real numbers excluding 0 here. So we'll exclude 0, and the range is r minus 0. Clear? Now let us take one more example. Find the range of fx is equal to 1 over x. So here's this is known as a reciprocal function. This is known as reciprocal function. Now this function is valid for all values of x except x equal to 0. So here x should not be equal to 0. So therefore the domain of fx is all real numbers except 0. Now to find its range, what we'll do? We'll write y is equal to fx is equal to 1 over x. So xy is equal to 1, or x is equal to 1 over y. Clear? So here we see that y takes all values except 0. So y cannot be equal to 0. So therefore the range is r minus 0. Clear? So hence we can say that the domain of fx is r minus 0, and the range is r minus 0. Viewers, now I am taking the last example of this discussion, and this is find the range of fx is equal to 1 over square root of x minus 5. So obviously this function fx, if for its domain we have x minus 5 must be greater than 0. Clear? For domain x minus 5 must be greater than 0. We cannot write here the equality sign, because in that case also fx will become infinite or not defined. So x is greater than 5. Clear? So what is the domain? The domain is x belongs to this is 5 to infinity. So this is the interval, and this is the domain of f. Clear? Now to find the range, what we will do? We will assume y is equal to fx equal to 1 over square root of x minus 5. Clear? Now we see that from this equation we can write square root of x minus 5 is equal to 1 over y. Clear? Obviously from this equation we see that x minus 5 is greater than 0. This term is greater than 0. So it means the square root of this term is greater than 0, and which further implies that 1 over square root of x minus 5 is greater than 0. So therefore we can say that y is greater than 0, and when y is greater than 0 means fx is greater than 0. So range is from 0 to infinity, or we can say y belongs to 0 to infinity. Clear? So viewers, in today's discussion we have discussed the concept of range of real functions, and we have solved many problems based on range of real functions. In our next videos I will take different type of functions like constant function, polynomial function, absolute value function, signum function, greatest integer function, smallest integer function, along with trigonometrical function. And in those videos we'll discuss the domain and range of these special functions along with their graphical representation. So keep watching my videos on concepts of mathematics. Till then, goodbye.